So let's actually make a particle system now. If we drop down a pop network, it's not really making the old Houdini pop network. If you're relatively new to Houdini, then you only ever knew about dot nets anyway. Back in the day, Houdini had a separate particle area, but they rolled that into DOPS now. But the benefit of typing in pop network by doing that is it sets up a bare bones system for you, so you don't have to make 4 nodes. So, saves you a few seconds, which I just wasted by talking about it endlessly. So let's say we got. Press play, not much is happening. Why is that? Well, it says use first context geometry, which, okay, it is coming in there, but we're gonna have to change this to all points so that it actually can source from that. Because as a sphere, it's, or as just a point, it doesn't know that that's where we want to source it from. Normally it would be looking for polygons. So anyway, so there you have it. So we have a stream coming out now, which is essentially our machine gun fire, or laser gun fire, or whatever you want to call it. I could drop a sphere down here if we just want to see. We could say copy to points, copy the sphere to there if we wanted to see. It's trying to shoot at that, essentially. Of course, they're moving just slow enough that they're always missing it. But it's enough that it's still tracing out the thing here. As you can see, it's passing through the path as it's going around. Great. So this is just for visualizing. We don't really need to concern ourselves with that too much. So it's going pretty slow, like I said. So first things first is I'm going to say, if we go over to our pop source here, let's say go 4 times as fast. Look at that. Now it's going much faster. That's cool. It's literally just multiplying 4 times whatever the incoming velocity was. Now I also know that I don't want it to go every single frame. This is going to be too many explosions. I mean, you might want to do this in your own sims, but for my own purposes, I think it'll look more dramatic. It'll feel more like each individual shot is more powerful if it skips a few frames between each one. So I'm going to say maybe impulse activation. Instead of activate on every single frame, let's activate whenever the frame mod 4 is 0. Now remember, mod 4 means, instead of doing a division, this means give me the remainder. So when f is 0, 0 divided by 4 has a 4 remainder. So that doesn't equal 0. When it's frame 3, 3 mod 4 has 3 remainder. But 4 divided by 4 has no remainder. So essentially, every 4th frame, that statement will be true. And when that statement is true, impulse activation is 1, which will do it. If you would need proof, right-click and hold, channels and keyframes, scope parameters, and you can see we get this rat-a-tat, pop, 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 every 4 frames. That expression evaluates to true. Great. And it's only emitting 1 particle. You just see it doesn't even let you choose because we chose all points. If we just chose points, then it might emit lots of particles per frame, and we get something weird like that. Or more like that. Impulse count is 100. It's going to emit 100 particles per frame. So essentially putting 1 here is the same thing as putting this to all points, because there's only 1 point incoming anyway. Great. So we got that. So what else we got to do? We needed to hit the ground. Right now it's just going, it's passing through the ground. It doesn't know anything about a ground right now. So let's see. Let's put a pop collision detect. There's a few ways you could do this, but I like to use the pop collision detect because it gives you the most options. So I'm going to point to that ground that we made earlier. So there it is, the grid. I'm going to turn off use deforming geometry because it's not deforming, so no reason for it to have to waste its time on that. And now we can see nothing's happening. Behavior, response is none. Okay, well, let's not have it be none. Let's have it stop. which makes sense. We want to record the location, essentially, of where it hits the ground. Now, now we can see them sticking into the ground. So we're really getting somewhere now. This is going to be the dynamic, basically, areas where it actually will source our little explosions from. So one issue, though, is that, they're not quite on the ground. They're kind of like, some are going below the ground, some are above the ground. That's pretty close. Let's turn on move to hit. Now, when it hits, they'll be right on the surface. See that? We could have wasted a lot of processing power by turning up the number of substeps, but this simply just says move it backwards along the velocity until you get back to where the actual collision occurred. Sometimes you don't need that, but we definitely want this case because we're only using this to spawn explosions on the surface anyway. So what else do we need here? Well, we're going to want to know for later that the hit happened on such and such a frame. So I'm going to make a group here for under group name, group hit. So all particles that just hit will be added to this group. We're going to want that again because that's going to be every frame we're going to look at what particles just hit. That's where we're going to have to do something else. We're going to have to spawn smoke, we're going to have to spawn rigid bodies or whatnot. A nice thing about this, I'm going to press Alt right bracket here. A nice thing about using these, the pop collision detect and whatnot, is you get a whole bunch of data for free. So I'm going to open out the pop object, click on geometry, and you can see over here, there's a whole bunch of attributes. I'm going to hide them all for a moment, turn on the hit time. So you can see it records when it hit the ground. Problem is, why does the hit time keep changing? So for particle 0, the first one that hits, it just keeps going up and up. And the problem here is that even though we set the response to be stop, because we moved it to where it hit, it's actually technically colliding every single frame because it's still, on the ground. It's in the ground in a way. So I want an accurate hit time. We're going to need to know that information later. And you can see how many the hit total is just skyrocketing as it goes along. So we really only want this to work. We only want it to detect this collision on the first frame. So this group made a group of all the particles that just hit, but this group, we will limit which ones will actually be detected. So let's put the hit total, that one of those attributes we just saw, only do this if it hasn't hit anything yet. So now we see the hit time stops. It just recorded the first hit. The age is getting older, which is fine. It's not moving because it stopped. And the hit total, you can see, stayed 1. Now that it's 1, this won't work anymore. And of course, it's running this per point. So we've got pretty much everything we need. We don't need gravity or anything like that. We just want to know where the explosion should be. We're going to want to know the orientation, actually, of the fire, which we get for free with the velocity. We're going to want to know when it hit. And that's about it. So we got all that. The output's already there. When we come back out on this side, we can see we have our points. And if we hide everything else, I don't want to see the, I'll turn the template on and off. There we go. I don't want to see the path now. So we can see the path being traced out anyway. So actually, I do want to see the path. Let me see that. There you go. Hit the path as predicted. Very good. And finally, we're going to want to know later on, we're going to want to know about that just hit business. Or really, we're going to want to know if it has hit the ground or not. So I'm going to say, are you stopped? And that is a point attribute, so set this to points, and you'll see the left one will be the guys that are hits. We'll call them stopped. That makes more sense. So we can see they're just showing up. So this is the current state over time of how many explosions we have and where they are. And our other output here will be the ones that have not stopped, meaning the ones that are still airborne. These will be our lasers. When we make our laser geometry and our lighting from the lasers, this will be that. So this has all the laser, and then it just disappears once it hits the ground. Great. So we've got our whole, that's our entire laser sim such as it is. Boom, 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 boom.